Welcome to this afternoon's course on Intermediate Python. This is a follow-on from our beginning Python course, so this will be assuming knowledge about the basics of Python, so it will be assuming you know how to make loops and dictionaries and lists and things like that. We'll be working through some slightly more intermediate material as a follow-on from that course. Now the first page of these notes here go through setting up Jupyter Lab. In the landing page there was a link to some videos which hopefully you've had time to go through to make sure everything's all set up. Otherwise, if you've been to our beginning Python courses, then you should all be ready to go anyway. But I'm going to go through that just in front of the room now to make sure everyone's up to speed, give everyone a minute to catch up, and then we'll launch into the actual material. So the first page of the course notes here are mostly going through getting Jupyter Lab set up. So I'm going to scroll down as far as the setup, and then there'll be a little bit of demonstration. So I've switched tabs now to Jupyter Lab. This was launched through Anaconda, and I've set it up in the same way as I showed in that video. So I've got a text editor on the left-hand side, in which I've already written a short Python script. Hopefully everyone here is comfortable with that level of Python at the very least. On the right-hand side, I have a terminal. In that terminal, I can run, for example, Python, and then space, and then the name of the script, which in this case is script.py, press enter, and it runs it and prints out what the script does. So throughout the course today, whenever we're doing exercises, I'll be asking you to do the exercises in a text editor and run them in the terminal. That's how you're going to be working on the exercises today. But in the course today, we're introducing a potentially new tool called the Python console, which I've opened up in a second tab on the right-hand side as well. So if I click on the Python console, this is where we can write and run Python code interactively. It works very similarly to a Jupyter Notebook, if you've used one of those, but we can write in here at the bottom, print, and then put something in the string, hello. I then run the cell with a shift enter. It prints the code and prints the response. So when going through the examples in the session today, I'll mostly be working in the Python console here because it lets me quickly iterate, but I might be using both modes at various times. So I'm just going to give you a minute now to make sure that you can A, write a Python script and run that Python script in the terminal, and B, that you can load a console and run some Python code in there as well. So as to your question, David, when you're writing code in the console, when you want to run it, you have to hold down shift and press enter. It might also be that control enter works. No, control enter doesn't work. So you have to hold down shift and then press enter, and that should run that bit of code. It looks like most people have managed to got things working now. So I'm going to just do a little bit about how the console works. So I imagine that most of you haven't come across the console before, so I'm just going to show you some of the features that it provides, which I think are quite useful. So I'm going to start off by making a list with some animals in it. So cat and dog. Normal Python list, something we've all seen before. I run that with shift enter. So L is now a list type. So if I want to do something to this list, we learnt about in the beginning Python course that we can call list.append on lists to add stuff to the end of them. So if we do L dot, but if we pretend now that we don't know what functions are available on the list, if you press the tab key just once, just press the tab key on the keyboard, then you get popping up a list of all the functions that can be completed. So you see there's the append function, that is the one that we want to do in this context, to add something to the end, as well as clear, copy, count, etc., etc. This works with more than just lists. This will work with any data type in Python. So you can always use this as a quick way of finding out what you can do with a particular piece of information. In our case, we want the append function, so either click on it or press enter. Then let's pretend that we don't know how to use the append function. We don't know what arguments it takes, and we don't know necessarily exactly what it does to the list. The Python console provides a way of finding help directly inside the console without having to go away and Google. And to do that, if you follow the name of the thing you want to find out about with a question mark, and then run that cell, and I run that cell with shift enter, you'll see it prints out directly in line a bit of information and context about what that function does. It does use some somewhat technical jargon, and for example, it tells you what the append function does by using the word append, which is a classic mistake. but it tells you that it's a function which takes one argument. The slash there's a behind the scenes thing, which means doesn't take any more arguments. But it tells us that whatever object we pass in, it appends that object to the end of the list. And that's a useful thing to know exactly what it does. It adds it to the end of the list, rather than the beginning or somewhere in the middle. That means we can go ahead and use it. So if you press the up key on the keyboard, we can then, that brings up the previously run command. You can keep on pressing up and you can cycle through. Up and down cycles through the recently run commands. Delete the question mark, call it like a function, and pass in something like horse. If we now run that with Shift Enter, the list has been affected, and it's hopefully added horse to the end. If we want to have a look at what is inside the list now, of course we can write print L as we've seen previously, and we can do with normal Python. But if you just want to have a quick inspect of what an object looks like, you can just type the name of the variable, nothing else, and then run the cell with Shift Enter, and it will display on the screen the contents of that variable. So it will show us what's inside it. So if you have a little go at that yourself now, using the question mark, making sure you can display variable names just by writing the name of the variable directly, and see if you can get tab completion working. So we'll move on to the next section of the notes. So I'm going to switch back over to the notes. At the bottom of every page, there is a next button. If we click on that, we end up on the next chapter. But let's go through string formatting and see what Python can do to help us. So if we go over to the console here, and let's have a look at some features. So these are features which were added in relatively recent versions of Python. There's always been ways of telling Python exactly how you want your strings to be formatted, and including variables in your strings as well. But they've added several over the years, and so I'm going to be showing you today the most up-to-date and most recent way of doing it. But first we're going to start with plain old print functions. So let's make a variable, something called mynum, and let's make it the number 42. We can, of course, print 42, and that shows up correctly. It does the number 42. No, sorry, I meant to say we can print mynum. And we run that, and it prints 42. So it's accessing the variable as we expect. We can also, with print functions, put in multiple arguments. So we can say something like mynum is, and there's a second argument, pass in the variable. And that prints out the first argument you pass in, automatically puts in a space, and then prints out the second argument you put in. So this works perfectly well. There's nothing wrong with doing Python coding this way. The potential issues are that it's automatically put the space in, and so maybe you don't want it to put the space in, you want to format things a little bit more neatly. And the second thing is, if you get lots of variables and lots of things going on, this can end up being quite a long string, and it's hard to see by reading the code what your output is going to look like. And so Python introduced a way of including your variables directly inside the strings, so you can see how it's going to be displayed at the end without having to construct it out of separate pieces. So to do that, we use a print function, and we write a string as we ever did. But to enable this special mode, you have to write an F just before the opening quotes. So you write an F and then the pair of quotes, and then inside the quotes we can use the special mode. So we write mynum is, but then instead of doing a comma and then passing a second argument, we can, directly inside this string, use curly brackets. Now previously we've seen that curly brackets are used for making dictionaries. This is a completely different use of curly brackets. It's a common problem in programming that there's only so many different types of brackets that they do end up being used for different purposes. But inside those curly brackets, we can just directly write the name of the variable that we want to use. So we just write my_num inside those curly brackets. And when we run that, it's going to write this and the space, and it sees the curly brackets and it's going to replace those with the value of the variable that's inside them. So run that with Shift Enter, and we get the same thing printed out. But here we've constructed one string which represents what we want the final product to look like, but we put placeholders in for where we want our variables to be replaced. You can do more complicated things, so we can write answer equals 42 and pi equals 3.14159 probably. Two variables there. And I can then print them out in an f string, all in one f string. So I write print, open and closing quotes, again putting the f in front of the string. And inside here we can write the answer is curly brackets answer, the name of the variable. And then outside again, and pi is curly brackets, the name of the variable. And so it's going to replace this with the variable answer, this with the variable pi, and we'll print out the answer is 42 and pi is 3.14159. You can put more complicated things inside the curly brackets. You don't have to just put a plain variable name. So I'm just going to copy and paste a dictionary in here. So here we have a dictionary, which has one key, which is answer, and a value 42, and one key, which is pi, and the value is 3 point whatever. If we want to print that using an f string, we can do our f quote quote thing again, and we can copy our thing from before. But this time inside the curly brackets, we want to get the value out of the dictionary. So the dictionary is called myDict. We use square brackets, and then we ask for the key from the dictionary. And we do the same thing here. myDict, square brackets to get the key, and we ask for the string pi. You'll notice here that I've used single quotes to get the string for the keys, to get the keys from the dictionary, and that's because I've used double quotes for the outside. So you have to make sure you don't use a double quote if you made your overall string using double quotes. Otherwise, it's going to think you're closing the string and it will get confused. But when we run this, we see we get the same thing printed out. So just spend a minute or so having a go with that, and then I'm going to set you the first exercise to make sure that the first exercise goes smoothly. And that's because we're going to use the first exercise throughout the course today, build up on it slowly, so we want to make sure that everyone's set in the first place. But first, have a go at doing this f string formatting and make sure that it's working for you. So if you go to the bottom of the string formatting chapter, and I'll do the same on my screen, you'll see a big yellow box with a big long-looking exercise in it. So inside here, there's a big chunk of code, which we are going to be working on and improving as we're going through the course today. We're going to be using it as the primary bit of code to do the exercises on, to learn and play around with the techniques that we're learning about. Luckily, this first exercise is nothing more than take this bit of code and run it. So I'm going to do the same thing as you will do. I'm going to copy this code. I'm going to move over my text editor. I'm going to make a new file, a new text file, put it over here, and I can close scripts.py. I'm going to paste all that code into that text file. I'm then going to rename it to encode.py. Because what this is doing, it is going to take a string and it's going to encode it into Morse code. Now the layout on the screen looks a little bit funky because of the line wrapping. But this up here is a dictionary which tells us for each English letter how to convert it to Morse code. So the first exercise is to take this code, paste it into a file, call it encode.py, and to then, in the terminal, not in the console, but in the terminal, to run it using Python, or if you've been told to, Python 3, encode.py. And you should get printed out incoming message, SOS, etc., and then Morse encoded dots and dashes. So to take a minute now to do that same thing, copy that from the example in the notes, paste it into a file called encode.py, and make sure you can run it in the terminal. Once that's all there, then we can move on and start learning about the first of our new techniques for this course. I'm seeing a few questions in chat. So the first one from Bryony, your syntax error. If it's saying that f strings are an invalid syntax, then there's a chance that it's because you're running on Python 2. So if you're getting that, when you run your code in the terminal, instead of writing the word Python, run the word Python followed by a 3, then a space, and the name of the script. And that will hopefully give you something that's working. F-strings were only introduced in a recent version of Python. So functions are the first in the journey that we're going to be taking today. The general theme of the workshop today is learning about how you can take your scripts that you've been writing so far and package them up, make them reusable, make it so you can share them, and make it so that it's harder to make mistakes when writing code and when people are using your code as well. That's the general journey we're taking, and functions are the first step along that route. So functions allow us to reuse code. That's their primary purpose. One of the biggest sources of mistakes in programming is when you copy and paste some code and you make some kind of mistake when you're tweaking your pasted version, and it makes a mistake and then your code gets something wrong and it's really hard to spot. Functions are one of the ways that you can avoid that problem entirely and make it so that you can have a single unit of code which can be used in lots and lots of different contexts throughout your code base. So I am going to go back to my console over here on the right, and we're going to have a look at how we can learn about functions. So I'm going to start off with an example not using functions, and then go through the route of turning it into something which can be reused. So let's start off with writing a little bit of code which is going to add together the contents of two lists. So we make a variable A, which has got some numbers in it, 1, 2, 3, and 4, and a variable B, which has got some other numbers in it, uninventively 5, 6, 7, and 8. When we run that, we've got our two variables ready to go. Then we're going to write our bit of code which is going to add those two lists together. And by add the lists together, I mean add the first two elements, i.e. add 1 and 5, put that into a new list. Then add 2 and 6 together and put that into a list, add 3 and 7, put it into the list, and then add 4 and 8. So we're going to be adding the lists together pairwise. In order to have something to put our result into, we have to start off by defining an empty list, which I am going to call C. Then we're going to write a loop which loops over A and B and adds them together and puts the result into C. So we write a for loop, and I'm going to write A element, B element. So A element will represent 1, 2, 3, and 4. B element will represent 5, 6, 7, and 8. For those two in, and I'm going to use a function called zip here, which you can pass multiple lists to, and it allows you to loop over both lists at the same time. So we pass A and B into the zip function. This is going to loop over the two lists simultaneously. The first time around the loop, it will give us the first item from each. Next time around the loop, it will give us the second item from each, and so on and so on. We then append our result into C, and we compute our result by adding together ALM plus BLM, if I can spell. We run this code here, and it's going to go ahead and do the calculation. Finally, we print C to have a look at what's inside it, and we see that C contains the correct result. We're going to be using this bit of code in a few examples today, so make sure you understand what's going on here. But with that, we're going to have a look at how we can turn this into something which is reusable. When you're writing code, whether it's a small script or something on a much larger scale, doing a large piece of scientific analysis perhaps, almost all code can effectively be broken down into three main sections. The first section is the bit where you read in your data and prepare your inputs. This is what we've simulated here by defining these two lists. The second chunk, and often the largest chunk of your script, will be the part where you do some kind of analysis to your data. Here we're simulating our data analysis by just adding together the two elements. This is where you might run some kind of simulation or a model or do some kind of numerical analysis to your data. The third section that's present in most code bases is then doing something with the output of that simulation. This is often something like save it to a file. It's often a very short part of your code. But thinking about your code in these three sections often helps you think about the flow of data and work out how you can construct a pipeline to analyze it in the most effective way. Because you'll often find yourself doing similar analyses each time, you'll often in 1 week be doing analysis which uses a particular function, and then later on you'll be using that same bit of functionality in a different analysis. It's useful to be able to package up the middle step into small pieces which can be reused in multiple places. And that's what functions allow us to do. So we're going to look at this middle part of our analysis here, and we're going to wrap that up into something which can be reused. And so instead of us having to use 3 lines of code every time to do that functionality, we can instead have a single line of code we run to call the function which implements it. So we start a function definition with the def keyword, which stands for define, because we are defining a function. We then give the function a name. And now this is the name we are going to use when we call the function. In the same way as we call the print function, somewhere there is a bit of code that says def print. Here we are defining an add arrays function. Then we need to tell it what arguments it should expect to receive. And we do that by using round brackets. Similar syntax to use when calling a function, but here we are just defining it. And we say that this function, when it's passed the arguments, is going to refer to them as x and y. So this function, when called, should be given 2 arguments. We then describe the body of the function. Notice that when I press enter after the colon at the end, it automatically indented. Like with for loops and if statements and so on, indented code means it's part of the thing that's above. So all of this code is part of the function. I'm then going to effectively rewrite this bit of code here, but inside the function. I'll use different variable names to make sure that we don't get confused. So I'll make a variable called z, which is going to be our accumulator. We write for x elem y elem in zip x y z dot append x elem plus y elem. Okay, and I made a typo there, append. And then last time that was all we had to do, because the C variable was left in the same level as everything else. So after we'd done our code, we could simply print C. This time, because we're inside a function, we've got our own little set of variables which are internal and private to that function. So in order for anything to get out of the function, to escape to the outside world, we have to explicitly return anything that we want the outside world to get access to. The thing that we want to return from this calculation is the variable z. And so to return it to the person who called the function, we use the return keyword, followed by a space, followed by the name of the variable. So the way we read this is we are defining a function called addArrays, which takes 2 arguments. Inside the function we are making a list, adding stuff to it based on some kind of calculation, and finally returning that new variable which we've just defined. If we run this cell, nothing has yet happened. We haven't executed the code inside. All we've done is define the existence of a function. But that means that we can now call this function in the same way as we do with print functions, sorry. We call it by using the name of the function that we just gave it, addArrays, and we pass it 2 arguments because that's what we defined it to want. It expects lists, and so we're going to give it the name of 2 lists, A and B. Notice that the lists in this top scope are called A and B, but inside the function they're called X and Y. That's perfectly fine. They don't have to have the same name at all, and in fact it's often better if they don't have the same name to avoid confusion. In the outside world we refer to them as A and B. The function knows them as X and Y. They're the same data, but they have different names in the different contexts. If we run this function, call it passing in A and B, and run that cell, I made a mistake. That should be append those added together, not add them as 2 arguments. Now, if we run this function, we get printed out the correctly added data. So we've got our 6, 8, 10, and 12, which is the correctly added together A and B lists. So Amy's asking, with zip, can you multiply, divide, etc. A and B? Absolutely. So if we look at our code here where we're doing our zip function, all that zip is doing is providing us with the elements from those two lists. So the elements of x and the elements of y are going into these two variables. Here we are deciding that we want to add them together, but we could just as well replace that plus sign with a multiply or a divide or absolutely anything else you'd want to do with those two variables in order to process the data as you see fit. So if there's no more questions, we'll move on to the next exercise. So going to the notes at the bottom of the functions section, it's a chance for you to have a go at writing some functions for yourself. So the first exercise here is to take that code from that last section, which I'll just show on the screen, and to turn all the code from here to here into a function. So to move that section of code inside a function by defining a function, defining the arguments. In this case, it will take one argument, which will be the message to be translated, and then to call that function and check that it's giving you the same result. Once you've managed to do that, there is a second chunk of code, which you can start by copying and pasting into a file called decode.py. And then you want to do the same thing to that chunk of code. Copy everything from the empty list creation to the join and put that into a function as well. In the first exercise of the two, your function should be called encode. And the second exercise, your function should be called decode. I'm going to give you a few minutes to do this. And if at any point you want a bit of help, either ask in the chat, but also note that every exercise has an answer link afterwards. So do feel free to have a look at the answer to see if you can learn anything from it or if you want a little bit of clarification. Lucas is asking whether it matters where you define the function. For example, in MATLAB, they have to be defined at the end of a script. In Python, you can define a function anywhere at all. As long as you've defined it before you call it, everything's going to work out absolutely fine. There's a general convention to define your functions at the top, but as long as they're defined before they're called, it will work just fine. And Luca is asking, when you define a function, does it remain in Python when you run it another time? No, a function defined will only remain as long as that script is being run. We'll see in the next section how you can write functions and have them used in multiple scripts, so you're probably predicting the future a little bit there. But on the whole, you define a function, it exists in that script, and you can use it for the rest of that one script. I'm going to go through turning encode.py into a function on the screen now in front of everyone. So whether you finish this section or whether you're still working on it, if you want to watch along to see how I'm doing it, feel free. Otherwise, if you're still working on the exercises and you just want to concentrate on that, feel free to carry on for a little bit doing that. So if we look at encode.py, the bits of code that we want to turn into something reproducible are the bits that actually do the conversion. These lines at the top of the file are our data reading in. They're setting the initial inputs to the whole thing. Both some data that's used for the conversion, as well as the message that we want to convert. These lines of code here are the bit that's actually doing the conversion. They start by making a list that we're accumulating into. They loop over the message and convert each letter in turn into the Morse code equivalent. And finally, once all of those converted letters have been put into the Morse list, we join together all of those Morse letters using spaces and put it into this variable Morse_message. So this is the section of code that we want to turn into something reproducible. This is the thing that we might want to call in different contexts. We don't always want to only call it on this particular message. We might want to call it on other messages. So we want to turn it into something reusable. We start off by defining a function. Define encode. Choosing a name for a function can be a little bit tricky sometimes. The main bit of advice I would give you is keep it short and use something which is generally an action or a verb. When you call a function, you want it to perform some kind of action, and so you should name your function in a verb sense. So this function is going to encode something. It's going to take an argument. The argument is going to be called message, and we end it with a colon. All of the code inside, we then want to indent, because that is all now part of that function. At the end, what we need to do is return Morse message. So the input comes in here, gets looped over, and then the output is put into Morse. We convert Morse into Morse message using the join, and then we return our final output. Now that we have our function, we still need to call the function. If I ran this code now, we would get an error saying, I don't know what Morse message is. So we need to make sure we call the function. I'm going to scroll down a little bit. And we call the function by using the name of it in code, call it like a function, and pass in the argument as message. The result of that function, which is what's returned here, needs to be put into a variable. And so let's call that Morse message equals. We can now save that and run it, and we get exactly the same output that we got before. The one thing I'd like to point out, which I alluded to before with our A's and B's and X's and Y's, is that this variable here is called message, but we're also calling the variable inside our function message. That's just because that's how the code looked before we functionified it, but there's no reason they have to have the same name. To make that clear, I'm going to change our internal variable names inside our function into something else. So I'm going to just call that, I'm going to call this M, and I'm going to call this M. So the message that we want to convert is called M, and that's the variable name we pass to the function. Inside the function, it refers to it as message, and finally returns Morse message. Also, these two variables don't have to have the same name. So to make that clear, I'm going to call our outside of the function variable Morse underscore M, and do the same thing with both of these. So outside of the function, we just have M and Morse M. Inside of the function, that's where we've got our long variable names. There's nothing implicitly wrong with using the same names outside and inside, but I wanted to show you that they don't have to be the same. And to demonstrate it, I will then run that bit of code. The process for the decode function works in exactly the same way. There's a bit of setup at the top, which is defining our variables. Then the bit that does the decode works like this. We've turned it into a function by indenting it, called it in code, finally called it, and printed it out. I imagine that some of you attending the course today might have done functions before. It's always difficult to know what the introductory level of everyone's knowledge is, but certainly by the end of the course today, we want to make sure that everyone's up to the same level with all the topics that we're covering. So I want to try and make sure we're not leaving anyone behind. So now we've got our encode and our decode files, and I'll show that Python decode.py works as well. It prints out SOS, we have hit an iceberg and need help quickly. We are ready to move on to the next section. So looking at this code so far, we've got some information that is being duplicated between these two files. So first of all, there's this letter to Morse dictionary at the top, which is in decode.py, but it's also in encode.py. So this is something which is central and core to the process that we're doing. It's some kind of static data that's being used as part of our algorithm to do the calculation that we're asking for. But there's other text or there's other code inside this file which is specific to the problem at hand. In this case, it's the message that we're translating. You can imagine this being a stand-in for the data that I want to analyze today, or the database that I'm getting data from that I'm looking at today. So there's some things in this file here which are usable in all contexts, no matter what kind of message I want to convert to or from Morse code. And there's some code inside these files which is specific to the task at hand that I'm doing today. And so the first thing to think about when you've got code like this is to start thinking about which parts of your code are today's job and which part of your code are going to be useful in the future when you're working on a similar task a week, 6 months, 5 years down the line. Think about which parts of your code are generalizable and which part of your code are specific to your job today. Once you've got in your head how various parts of your code base fall into one category or another, you can start making it so those parts of your code which are generally usable can be extracted out and put into something which can be used in multiple different scripts without having to copy and paste them. And this is how we're going to carry on our journey towards making our code more reusable and harder to make mistakes with. The first step was we've got some lines of code, and so we turn it into a function so that we have a defined interface of what goes in and what comes out. And so we no longer have to care about what's inside the function. We just call it and we expect and assume that the internal is going to work correctly. The next step along that path is to take the parts of your code which are reusable and to put them somewhere where all your scripts can find them. And that is a feature of Python called modules. And so to demonstrate it, I'm going to show you how we can do it with the add arrays example that we were playing with before. I'm going to make this a little bit bigger here. So I'm going to make a file called arrays.py. And inside that, I'm going to put that same function that I defined over there on the right-hand side. So this is a normal Python file. It is as you've written any other time. There's nothing special about it, but this is going to turn into a module as we work through this little section here. To turn a Python script into a module in Python requires no work whatsoever. We have our arrays.py, which has inside it a function. That means we can go to our console and we can write import arrays. You might have seen import used when you're working with, for example, NumPy or pandas or other third-party modules that you might have used before in Python. But this allows you to write your own modules, which you can put in functionality which you want to use in different contexts yourself. When we write import arrays, it's going to first of all look in the current directory for a file called arrays.py. And because we've just created one, it's going to find this file and it's going to import this module. We run this with Shift Enter. We can then do arrays dot, because dot is how in Python you get access to something that's inside something else. We have the arrays module, which is this whole file on the left-hand side. And from that module, we want to import the add arrays function. Now, if your tab completion is working, you should, after typing arrays dot, be able to just press tab, and it will show up there arrays.addArrays, and it's a function. We can then pass in A and B and run it, and it gives us out our answer. Now, this addArrays function is the one coming from the module arrays, which is the one that's defined over here. And that means as long as this file is in our directory, we can restart our computer, we can change and restart the console, but as long as we write import arrays, we should get access to it. If you're having any issues with this, and I'll give you a chance to have a go with this yourself in just a moment, the first thing to check is that you've saved your arrays.py file. Up here, you should see a black X next to the file name in the text editor. If you see a little black circle next to the file name, make sure you've saved the file by going to File, Save, which is Control S or Command S. If you have done that, then the next thing to try in the console is if you right-click in the console and select Restart Kernel, that will clear everything out after pressing the big red Restart button. You have to scroll down sometimes, at which point we can import arrays again, define our A and B, and then we can call arrays.add arrays A, B. So if you're having issues, try right-click, restart kernel, run those lines of code again, and see if that works. I'm going to give you a minute now to have a go with that yourself. Then I'll carry on with the next little section. So Katie's getting an error, module not found error, as is Sophia. So the first thing to check there is that, as I said, when you do import arrays, it's going to look for a file called arrays.py in the current directory. So inside the box here, try running %ls and then press enter, and you should see the same list of files here printed in the console as you do on the left hand side in the file browser. If you see a different list of files, then you will have to make sure that you're in the same directory between the two places. So check that you're seeing the same list of files first, and if you're not, then let us know. Good, I'm glad that fixed your problem, Katie. It does get a bit confusing, and Jupyter Lab isn't always very good at keeping everything in sync. So that's always worth checking that you're in the right directory in all of the different places that need to be kept in sync. And Sophia, if you're not in the right directory, so for example, I'm going to put myself in the wrong directory. So on my computer, my code is sitting in home mat temp/python. I've put myself into the wrong directory. There we go, that's working. But if you want to move, then %cd space the name of the directory you want to move into, which is Python. CD stands for change directory. Run that, and then %ls should work. Kunal points out that if you put in different length arrays, then the resultant array has the length of the shortest. That's a very good point, and later on in the course today we'll be learning how we can check for errors and raise errors in those situations. But to demonstrate what you're talking about for everyone else, if I make A and B different lengths, and then run the function, we see that 4 never gets added to anything. Now there's two reasons for why that happens. Firstly is that there's no definition of what 4 added to nothing would be, and so it makes sense that it's not able to guess it. But the real root cause for it is that the zip function only loops over the arguments that passed in as long as they all have elements left. As soon as one of the arguments passed to zip runs out, the whole thing stops. That's something to be aware of when using zip. Bryony, you're seeing name error, name arrays is not defined. Make sure that you have run import arrays before you try and call the function. So you have to import arrays. You have to do that every time you restart the console, every time you do a new script, in order to make sure that arrays has a folder called my code. You could run something like mycode.arrays, and it would look inside that folder for that module. Otherwise, when you've got much larger collections of code, there are places you can put them centrally on your computer where it will always be able to find them regardless of which directory you're in. The next thing I want you to do is the exercise at the bottom of the modules page. So in this exercise, we're going to take the code from our encode.py and our decode.py, and we're going to extract the common core elements and move them into a file called morse.py. Then we're going to edit our encode and decode to import Morse and call the functions that are defined inside the Morse module. You can test it in the Python console if you want to, but if you do, you will have to do the right-click restart kernel trick. Otherwise, it's not going to import any changes that you make to your modules. But spend some time on that. Make sure you're able to convert your Morse code stuff into one module called Morse, and then import it in the other two files. I'll go through the answer to that exercise now with you all, how we can turn our Morse code functions into modules. So I'm going to close arrays.py. I'm going to make a new file over here. And I'm going to call this file, rename morse.py. So encode and decode are going to represent our tasks that we want to do today. We're going to pretend that we're a Morse code operator. We've received a message and we want to turn it into Morse code. And this script here should just do the task at hand. It should define an English message, and then it should work out what the Morse code message is. Likewise, decode.py is just going to define a Morse code message. It's then going to call the decode function to get back the English message. All of the stuff that does the conversions, we're going to move into Morse.py. So the first thing we want to move in is our two functions. So we take decode. I'm going to cut it with Control X and paste it into Morse.py. And I'm going to do the same thing with encode. And paste it into Morse.py. So we've got our two functions in here. But if you look at the encode function, for example, it's taking in one argument, which this function is going to refer to as message. So inside this function, using message as a variable name is valid. We can access that. We define the Morse variable. We loop through message to make a new variable called letter. This is all fine. This is all consistent. On line 6 here, we try and access the letter to Morse dictionary. And from the point of view of this function as it's written, it doesn't know what the letter to Morse dictionary is because it's not inside this module. And so we need to make sure we also move in any data that these functions need into the module as well. And so that is the letter to Morse dictionary, as well as this bit of code which calculates what the Morse to letter dictionary is. These 4 lines of code here invert the dictionary, turn keys into values and values into keys. So I'm going to take these two variable definitions here, I'm going to cut them, and I'm going to paste them into our module. I'm going to save that file, and I'm going to get rid of it out of here because we don't need it in here anymore, because it's not used anywhere in here. And you see that has massively simplified the encode and decode files. They are just dealing with a task at hand, defining a message, decoding the message, and printing the decoded message. All of the complicated stuff is locked away inside Morse.py, which the users, encode and decode.py, don't have to care about. They don't have to understand what's inside here. They just have to trust that calling those functions is going to work correctly. We can do a quick test of this by going over to our console, doing import Morse, Morse.encode, and let's encode SOS because I know what the answer should be. Gives us back ... .. So this function here is doing the right thing. We've got it from the Morse module, which is Morse.py, called the function, it's given us the response. In order to do the same thing to our encode and decode files, there's one other change we have to make, and that is we have to explicitly import our module that we've just created. Imports in scripts always go at the top of the file by convention. So import Morse. And now encode as a bare name doesn't have any meaning by itself. It is now inside the Morse module, and so we have to write morse.encode. Importing a module doesn't automatically make everything inside it globally available. It keeps it inside what's called a namespace, named after the name of the module, which we access inside using the dot syntax. This means if we go to our terminal down here and we now run python encode.py, it's printing the right thing. We can make the same change to decode. Import Morse, Morse.decode. Printing out correctly. And so now still our job we're working on today's script is nice and short and to the point. We define our data, we process our data, and we print the result. Likewise with encode.py, define our data, do something with our data, and then print the result. The complicated stuff's locked away in the module, Morse.py, and once we've written it and it works, we don't have to worry about it again. We can just import it and use it. We saw before how moving our code into functions allowed us to define the interface that they had. We would say this function should have these inputs and it should have these outputs. We also then saw how moving them into modules allows us to reuse those chunks of code in different contexts, in one file or in another or in the console. The last thing I wanted to show about what modules and functions provide for us is the ease with which we can test that our code is working how we expect. If I make a new file up here, I'm going to make a text file called test_morse.py. I've got a module called morse.py, and alongside that, I'm going to make a second file called test_morse.py. So it's the same name, just with test in front. This is a convention I like using for every module that I write, to write a file alongside it with the same name but with test underscore at the beginning, in which I put a little bit of code which I can run to check that the module is doing what I expect. So in order for that to work, we have to start by importing Morse. And because our code that we've written is an encoder and decoder, that allows us to test what's called a round trip. We encode a string, decode it again, and check that we get back what we started with. So let's make a message, hello everyone. We then make a new variable code, which is created by doing morse.encode message. I then take the result of that and pass it to morse.decode straight away without doing anything to it, and assign that to decoded. The last thing I do is then print out, checking that message is the same thing as decoded. If message, which is our starting thing, once it's been encoded and decoded, is the same as the result, then we know everything's working well. And so I can run this script anytime I like with Python test morse.py, and as long as it prints out true, I know that everything's working. And that allows me to go to my morse.py, change stuff around, fix bugs, try and re-implement it in a different way. And as long as my test is returning true, I have decent confidence that the code is still working and that I haven't broken anything. This is something I highly recommend getting the habit of doing. This is the first step towards testing your code, but there are much more flexible, powerful, and useful techniques that you can use, and we cover those in our other course, Best Practices in Software Engineering. So do check out that course if you're interested in seeing how you can do more with testing. But for now, in this course today, this gets us most of the way there towards checking that our code is working how we expect. We're now going to move on to the largest chunk of the course today, if I go to the notes, and that is classes and objects. Now, classes and objects are something that a lot of people struggle with when they first start learning Python. It does take a bit of a conceptual shift as you're going through, but I'm hoping that I can take you on the journey today to show you how they can be useful and how you can use them in your own code. They fit in the same kind of story that we've been telling so far. We started with functions, which allow us to package up chunks of functionality and give that a name and make it so we can reuse it in different places. We then packaged up those functions and put them into modules, which allowed us to use that function in different scripts or in the console, however we saw fit. The next step along that journey is to learn how we can package up not just bits of functionality, but combine together data and functionality all into one blob, which we can reuse in whatever context we see fit. And the way that Python and most programming languages provide that is using a technique or a feature called classes. Through the example here, we're going to be writing some code which represents a dog. And so I'm going to go ahead and start writing some code. I'm going to do it in the console because we're going to be interacting with it. I'm going to restart the kernel just to clear everything out. And I'm going to clear the console cells just so that it's a nice clean slate. So let's make a variable called our dog. Now, the dogs that we're representing inside this code here are going to have a couple of attributes to them. And of the functionality that we've learnt so far, either this course or previous courses, the obvious thing that we'd reach for would be a dictionary, a thing that we can use to bundle together a bunch of disparate pieces of information. So let's go ahead and make a dictionary. The key is going to be name, and I'm going to get some audience participation here and ask in the chat if anyone has an idea of what we should call our dog. I'll go with Bruno. Bruno. The other bit of information we're going to store about our dog is its colour. Now, what colour is Bruno? I guess brown would be the obvious answer, but anyone got any other ideas? Yep, let's go with brown. That's fine. And I'll do lowercase b. So, this is a dictionary which defines our dog. Its name is Bruno, and it's a brown dog. Now, this is a perfectly reasonable way to represent data. As you're developing code with Python, you're bound to very often reach for dictionaries as your way of bundling together disparate pieces of information which are related in some way, and where you want them to have names which you can assign and use to relate to different parts of that object. Because once we've got our dog, we can obviously do something like our dog square brackets name, and it prints out Bruno, so we can get the data back out again. Let's imagine, however, that we've got a function, def, called describe, which is going to read in this dictionary and print out a message which summarises the core essence of this dog. So it takes one argument, which we're going to call dog, and inside the function, all it's going to do is return a string. In fact, it's actually going to return an f string, as we saw before, which says dog. No, I need the curly brackets. Name is dog colour. So it's going to print the name of the dog, the word is, and then the colour of the dog, depending on the argument that we pass in. We've now got our function defined and usable, so we can now call it describe our dog. Bruno's brown. Good. That's all working fine. The issue comes about when you realise that this function here is making assumptions about the type of data that's passed in. A cursory glance of this, or a comment describing this function, might say, this function describe accepts a dictionary describing the dog, and it will print out information about the dog. That's a one-sentence summary of what this function does. But actually it's more than that. It requires that the dictionary has the key name, and it requires that it has the key colour. If you pass in a dictionary which doesn't have one of those two, then it's not going to work. It's going to raise an error of some kind. And so when we're describing how this function works, we would have to tell any users of the function, you have to pass in a dictionary which describes a dog, and that dictionary must have the keys name and colour. And if they make a mistake with that, they're going to get errors, and they're not necessarily going to understand why. One of the important things that you can do as you're developing code is make it so that any functions you write have a well-defined interface, which makes it hard for people to use them wrong. If you write a bit of code which people easily misuse, then it's not going to get very widely shared and people aren't going to want to use it. They're going to want rigid rules which allow them to avoid mistakes as much as possible. And so the main way that we can take something which is a dictionary and create some kind of data type which has a rigidly defined set of parameters or attributes on it is using a class. At its core, a class is a data type which has a strict list of parameters which must always be there, and you can rely on them being there. So let's see how we can take our definition of a dog and turn it into a class. Like with functions, which we start by writing def, we define a class using the class keyword. We then give the class a name. The convention in Python with classes is that you give the name of the class a capital letter at the beginning, as opposed to variable names which use lowercase and underscores. This helps someone reading your code to easily see what are classes and what are variable names. We then follow that with a colon, and then we are writing the code inside the class in much the same way as we do with functions or if statements or for loops or anything else. The main things that sit inside classes are functions. And so we're going to define a function now which is going to describe what a dog looks like. So we do that with def. Now the special function that we have to create to define what a class looks like is called underscore underscore init. There are 2 underscores before and 2 underscores afterwards. This is a special function which is called in order to initialize the class. It's going to set it all up so that we know it has the parameters and the attributes that we expect. It takes arguments because it's a function. All class functions always have to take an argument called self at the beginning of their list, followed by any arguments that we want it to accept, which in our case are going to be name and color. And it's a function, so we end it with a colon. I'll come back to explain how init and self relate to each other in a little while, but for now we're going to make this dog class, use it, and see how it works. Inside this function, we are going to set some variables, and we are going to set those variables. We're not going to return them at the end, but we are instead going to attach them to this variable self. This variable self is representing the dog in question at the moment, the dog that we care about, the dog that we are currently initializing. And so if you do self.name, we are talking about the variable name that's attached to the object self. We assign that the argument that was passed in name. We do the same thing with color, self.color equals color. At this point, we have finished defining and describing our class. That's all you need for a class that has 2 attributes on it. So we run that cell with Shift Enter, and it gives us back no error. So it's worked. That class now exists. In order to make an instance of that class, we call it like it's a function. We name the name of the class followed by brackets. The arguments that we put inside the brackets are the arguments that are going to be passed into the initialize function, not including self, because self gets handled automatically. It's the other arguments that get passed in. So we can pass in Bruno and Brown. We want to assign this to a variable, so let's call it our dog again. We run that, and that has created an instance of the class dog, which we are now calling our dog. Dog with a capital D is a class. This code here defines a class. This variable here, which was created from the class, is what's called an object or an instance. Now that we've created this thing, we can go ahead and use it. We can say our dog.name, run that, and it tells us that our dog is indeed called Bruno. So we're accessing attributes on our dog with a dot syntax followed by the name of the parameter that we care about. And that is in contrast, if I scroll up a moment, to our dictionary style, where we gave the name of our variable followed by the square brackets syntax. So if you've got a dictionary, use the square bracket syntax. But because we're now inside using a class, we can use the dot syntax. We can obviously do the same thing with dot color, and we get out brown. This means we can now adapt our describe function so that instead of taking a dictionary and assuming that there's a dictionary being passed in, we can have it so that it assumes a dog object is being passed in. So here, instead of instead of dog square brackets name, we do dog.name, and instead of dog square brackets color, we do square brackets color. We can now call the describe function on our dog, and it prints out Bruno is brown. So take a minute now yourself to write this code, copy it in. It's all written in the note, so feel free to copy and paste it from there or use that as a reference. Spend a minute writing that code, running it, making sure you can make instances of your dog. You can get the attributes out again and adapt the describe function so that you can pass in a dog object using the dot syntax, get the attributes out, and describe the dog and have it all work correctly. One way of thinking about a class in Python, and in fact in most programming languages, is that it can be seen as a template with which you can create objects. So the code here doesn't represent one single dog, it represents all possible dogs we might want to create. So here we created one instance of the dog class, we called it Bruno, and we called the variable name our dog. But we can create more. We can create an other dog, and there's been some great examples of dog names in chat, and let's go with Achilles. And what colour is Achilles? Achilles is blue, a very unusual colour for a dog. It's probably been mistreated. There we go. And I'll just run that our dog Bruno line again, so they're next to each other. So here we've called the dog class 2 different times. Each time we've called it, we've created a different object. And so the way that works when you're inside your class is that when we called our dog, and we call dog Bruno Brown, dog is then going to look at the dog class. Because we're calling it with the brackets, it's going to create an instance of that class, which is going to need to be initialized. And so Python will automatically call this magic function underscore underscore init, sometimes called dunder init for double underscore init. And it's going to pass in the 2 arguments that we passed in here as name and color. The self object here is referring to the same thing as what's going to get passed out at the end. So self here refers to the same thing as our dog. And so when we do self.name, we are effectively doing our dog.name equals, which is why our dog.color, our dog.name give the right thing. When we call this class a second time, when we did other dog, this time in the function, name and color are obviously different because we're passing in different arguments, but self is also pointing at a different object. Self this other time is pointing at the same thing as other dog. And so self is the special argument in any class function which gives you access to the object that you're currently talking about. And so because self allows us to talk about various different things about the class, we can use it both to put data into the class, we can also use it to get data out. And so now let's see how we can extend our class here by adding some functionality to it. I said at the beginning that classes combine data and functionality. So far our class is all data. It just defines some data which is held by the class. We want to give our class some functionality as well. And to that end, I come back to our describe function. At the beginning, I was lamenting the fact that you have to remember not only that the first describe function, if I scroll up, took a dictionary and you had to remember to pass in the right dictionary, you had to also make sure the dictionary had the name and the color attributes or keys inside it. We improved that a bit by saying that our describe function here is going to enforce that as long as you pass in a dog object, it will always have name and color, because both of those variables are always defined inside the init function. But we still have the possibility that we could pass something completely wrong to dog. We could do describe hello, and when we try and run that, of course we get an error because describe function doesn't understand how to describe a string. It only understands if it's passed a dog object. And so what we want to do is make it so that our function can only ever be called on a dog object, and it can't be used outside of that context. And so I'm going to bring up our definition of dog again and run it so that it's on the screen. I'm going to go back up to our definition of our class, and I'm going to show you how you can take this function that's currently freestanding and move it so that it's a function inside the class. I'm going to copy the code because it's going to be only a short few steps. We move it so that it is alongside the init function. We paste this code here, and make sure that it's indented so that it's at the same level as init and the internal indentation is all the same. The next thing we need to do is, like we had with the init function, the first argument was self. Here, the first argument of describe is going to be self. And as self here was referring to an object of the class dog, likewise, self here can refer to an object of the class dog in the same way that the dog variable in our freestanding function did. That means we can simply rename this variable to be self, rename this variable to be self, and rename this variable to be self, and that's all we have to do. We have now moved the describe function inside the class to be a class function. Class functions are sometimes also called class methods. Those two bits of terminology are somewhat interchangeable in Python. Now when we define this class, it has got two functions on it. I can make our Bruno dog again. We have to recreate our dog because it was still referring to the old version of the class. And that means that we can now do our dog dot, and instead of doing dot name or dot color, we can now do dot describe. Notice that we don't put anything in the brackets of describe, and that because in the same way as self in the init function was automatically put in there, in the describe function, likewise, it's automatically passed in, where the argument that's passed in as the first parameter to describe is taken from the thing in front of the dot. So writing our dog.describe will call this function with our dog passed in as self. And that means inside the function, self.name is doing our dog.name, and self.color is doing our dog.color when we call this function here. So that means if we run this code, it gives us back the description of our dog. And there is now no way to call this describe function on anything that's not an dog type. If we try and make a list and do l.describe, that's not going to work because the describe function isn't defined on the list type. It's only defined on the dog type, and this will give an error. So I'm going to ask you to take a moment just now and do this same exercise with your dog class. Take the describe function, move it inside the class so it becomes a class function or a class method. Redefine your dog. Of course, you can give it any name and color that you wish. And check that calling our dog.describe does the right thing and prints something out. Take a minute or so now to do that, and then we'll be moving on. Harry, you're seeing a strange output of bound method dog.describe and then a whole lot of hexadecimal, and I bet I can reproduce that. So I imagine what you've done is type something like our dog.describe and then haven't passed the brackets afterwards. So if I run that, I get a very similar thing. And this points to an interesting feature of Python, which we cover in more detail in our parallel Python course, and that is functions exist as objects in their own right. If you don't put the brackets afterwards, it tells you that thing you just told me about, that's a function, or as it calls it, a method that's been bound to the class. And so if we put the brackets afterwards, it does the right thing. So far, our dog is a little bit sad, really. It has a name and a colour, but it doesn't have any functionality. It can't do anything. It's entirely static. We create it, we give it a name and a colour, and then it exists in that form, changeless for eternity, or at least until we turn off our computer. We want to have the ability to represent data inside our classes which can potentially change over time. Something which is going to represent the state at one point in your program, you call some functions and it keeps track of things, and it has a different state at another point in your program. So we're going to make a new parameter or new attribute of our class, which, unlike these two arguments here, we're taken from the argument list, you can just make static data which is attached to your class. So we can make a new variable, self.energy. This is going to represent how much energy our dog has. Now, if anyone has had a dog, you'll know that they have a lot of energy. But we're going to pretend that initially our dog is always created with an initial energy of 1, and some kind of units undefined. So this parameter here, this attribute, isn't being defined based on an argument being passed in, it's just statically defined to any new dog that's created to always have an energy of 1. So if I create that and I make our Bruno dog again, in fact, let's make a different dog because we've had some good examples in chat. We had one earlier called Corona. And I'm going to make Corona gold. So now our underscore dog dot energy is number 1. It's got an energy of 1, so we've got some information about it. So that's all very well. We can, change the energy to be 100, and then it's got an energy of 100. But it's nice to, instead of having to dive into a class directly and change its parameters, to instead have functions which do the actions which we want this class to perform and keep track of the internal state for us. So we're going to be adding some more functions to our class which allow us to exercise our dog. So the exercise function is going to reduce the amount of energy that our dog has. So we go back to our class here, and we're going to add another function, def exercise. Again, it takes the self parameter, self argument. It's very easy when you're writing functions into classes to accidentally forget the self, but you'll quickly notice it when you try and use the code. And the exercise function or method is going to print out a message telling us that you take self.name for a walk. And then it's going to do self.energy. Notice that self here is the argument that's passed in, so it's going to be referring to the same thing as this. Minus equals, that's how you decrement or decrease a number by a certain amount, 1. So this function will print out something and then reduce the energy by 1. So if we make our dog Corona again, we print out the energy. Our dog dot exercise. It prints out the message. We took Corona for a walk. If we look at the energy a second time, we see the energy is now 0. If we make a second dog, to draw home the point that each dog object is an independent thing, if we make our Bruno again, other dog, other dog dot energy has not changed. So each dog has got its own internal energy attribute which it's keeping track of. So have a go at implementing the exercise function now, as well as adding in the energy parameter. Once you've done that, have a go at making a fourth function on the class called feed, which is going to feed the dog and increase the energy by 1. I have on a screen here the example of the feed function. So the feed function works exactly the same as the exercise function. It prints out a message saying that the dog eats the food, and then it does self.energy plus equals 1 to increase the energy. So if we define that class, redefine our dog, we can now do other dog dot feed, and it eats the food. We can do it again, and it eats the food again, so that if we look at other dog dot energy, the energy is now 3. So it's a dog with an infinite appetite, which will accrue an infinite amount of energy. But such is life when you're simulating things on the computer. There's some text on this chapter here, which is explaining how this stuff all works. So do have a look at this text later on. All these course notes will stay up permanently. So do have a look through the text here if there's anything you're not clear about. But have a look at the exercise at the bottom here. which is to edit the morse.py script, which is our script which is holding our library code, our functions and our static data, and to create two classes. One a class called English message, which has the encode function moved inside it, and another class called Morse message, which will have the decode function moved inside it. And then to change test.morse.py or make a new file called test.morse.py, which imports those two classes, makes a string and an English message from that string. So this is calling our first class. Calls the encode function on it to get back the encoded text string. Then to take that encoded string and to make a Morse message from it, and to call the decode function on that, and to check that we get our answer back at the end. Have a look at this exercise and see if you can create a class for the encode function called English message and a class for the decode function called Morse message. Again, there is an answer at the bottom of the section, so do feel free to have a look at that answer in case my description of the question isn't good enough, or if you want any help along the way. And likewise, feel free to post in the chat if you have any questions. I'll give you a few minutes for this one because it's a little bit trickier. As to your question there, Emma, about it not changing the energy, I'm going to show you on the exercise here what you've done. So you've written return that string in the same way as you did in the describe function. And that means as soon as the exercise function gets called, it's going to return that string and the function is going to end, which means it's never going to get to this second line here. Instead, change it so that you write print as a function so that it prints that, outputs it, and then carries on to the next line. And that should then work. Gunar's asking, what if I don't put init in a class? So in the example here, if I didn't have an init function at all, it would still work. It would mean that you can only call your function or create an object of your function without any arguments at all, which means that none of the parameters or the attributes of it which are assumed to be there will be created. You will effectively create an empty class which has no data, which only has functions. It's a perfectly valid thing to do if you want to bundle up a few of your functions under some kind of namespace. But on the whole, you usually want to have some data in your class as well as functions to act on that data. I'll go through the answer to that exercise on the screen now, so you can all see how I can convert a function and some associated data into a class which is encapsulating both of those things. The easiest place to start is with the function here, and we write class English message. This class is going to represent a normal string, an English string, which is going to have an encode function on it, which is going to return to us the Morse encoded string. We want to indent this, and we'll come back to the rest of what we do to that in a moment. We have to make an init function, and the init function, like all functions, takes self, and that is and message. So we're going to make one class which represents a message, and that message is going to be wrapped up and saved into the class with self.message equals message. The other thing that we want to save into our class, because we want to use it inside our function, is the letter to Morse dictionary. So I'm just going to copy, in fact I'm actually going to cut it, and paste it into here, make sure everything's indented nicely, and write self.letter to Morse. So this is saying that our class is going to be initialized, or an object of our class will be initialized with an attribute message, which comes in from what's passed in as an argument to the constructor, as well as an attribute which is storing our conversion dictionary. That means in our function down here, where we are going to be converting our message, it has to take the self argument. Now message isn't going to be passed as an argument to self, and that's because we don't need to anymore, because we can access message through self as self.message. And so here, instead of writing message, we want to write self.message. And here, instead of writing letter to Morse, we want to talk about this letter to Morse up here. So we write self.letter to Morse. And I think that is all the changes we have to make. So I'm going to save that file. I did, when you weren't looking, make the same change to the Morse message class, which has got a self.message, a self.morse to letter attribute, and then the same decode function, which had the same stuff done to it. That means that we can come over to our test Morse file, which imports English message and Morse message. It's going to call the English message class and pass in a string. That is going to call this init function with message as the string, which will then be saved as self.message. It calls the message.encode function, where message is the object of that class we just created, which is going to call this function here, do the same stuff as we've been doing so far, and return our message out at the end. That goes into code string. We can then stick that back into the Morse message class and do the same thing in reverse, where we call it, make a Morse message object, call code.decode, and then compare the two. So now hopefully when I run this over here, I will get out true printed. So that means we now know that everything is working. We could also do from Morse import English message, English message. We'll do our SOS again. Let's call it M. And we can do m.encode, and we get back our Morse code. This means we can't accidentally call encode on something which is a Morse code message, and vice versa. It makes sure the type is holding both the data and the things that we can do to it. No one's piping up in chat to say they're having any problems or have any questions. I will say that classes in Python and in any language are often one of the biggest increases in complexity you come across when learning the language. Hopefully I've done a good enough job of explaining how they're used, how you can construct them, and what their purpose is, but they do sometimes take a little bit of experience and practice to get the full value out of them. Kunal is asking why I wrote from Morse import English message there. So I could have written, exactly as I did before, import Morse, and then done Morse.English message, SOS. That gives us back an object of that class. But by writing from Morse import English message, I've extracted out just the one thing that I care about from the module, and so I get access to the class name just by itself without having to write Morse in front of it. So the last section that we'll cover today, actually no, before we do the last section today, a thing about naming. I did mention this earlier, but classes often have these capital letter names like Morse translator or dog. Whereas variable names and function names use this snake case. It looks like a snake because it goes on the ground and it's got sort of up and downs to it. So snake case in Python is used for variables and functions and modules, in fact. Whereas camel case, and it's so called because it's got these humps, is used for classes. If you stick to this convention, then other people reading your code are going to understand what's going on. So the last thing I'm going to cover today is on the next section of the notes, and that's handling errors. So going back to our console, let's have a look at what these dog classes can do. So let's create our dog again so we know what state it's in. And let's make a other dog equals dog Bruno Brown. So we've got our dog defined. Our dog can do things. We saw before, we can perform actions on the dog. We can call these functions, and we can do other dog dot exercise. That works fine. And we can do other dog dot exercise, and we can exercise it, and then we can do other dog dot exercise, and it keeps on walking and it keeps on working, and everything seems like it's all working well. And that is until we ask the dog how it's doing, and we look at the energy of the dog, and we see that somehow its energy has ended up negative. Now, under very few definitions is a dog with negative energy doing very well. And this is because we've allowed our exercise function to arbitrarily keep on reducing the energy attribute by 1 every time we call it, without any checking that it has energy to go for a walk. And so let's look at what tools we have at our disposal in order to make sure this stuff is being checked as we're going through. So the main tool that we've had at our disposal so far for checking stuff is an if statement. So let's go ahead and use the tool we already know and see how far that can get us. So we only want to exercise if self.energy is greater than or equal to 1. If it's 0, then the dog can't go for a walk because it's going to end up with negative energy by the end of the walk. We are going to allow the dog's energy to get to 0. That just means it's very tired. So if the energy is greater than 1, we allow it to happen. And so if we run this code, define our dog, and make our dog, and then exercise it, we get the message printed. If we try and exercise it a second time, we see that no message gets printed. We can exercise it as many times as we want. But if we go back and check what the energy is, the energy has stopped at 0. It's never gone below 0 because we are checking as we go along that the state of the system that we're looking at is in some kind of sensible situation. Of course, it's very easy to miss that this one printed something and this one didn't. And so we really want to, when we're printing these things out, to print something else in the situation where the dog is out of energy. So let's write else, and I'll copy and paste this. The dog is tired, it doesn't want a walk. So if we now run that class and define it, make our dog, and try and exercise it, it works once because we reset the energy to 1 in our initializer. If we try and do it a second time, it tells us that it's unhappy. That's good. We've now got something printed in the good state and something being printed in the bad state. But when you're writing code which is going to be used by other people, it's still very possible to ignore this line accidentally. If, for example, we do this same line of code multiple times because we think that everything's working fine, and then we do afterwards other dog.describe, because we've seen here that we've run this 3 times, we're going to expect that the energy is going to be 3 lower than it was. Now let's look at energy. But actually, it's silently failing, and it's allowing these more exercises to carry on. It's allowing us to keep on trying to walk our dog without us being told explicitly and forcing us to make a decision to notice that it is in fact tired. And so the way that you can raise an error in Python which the person calling your function can't ignore is with a thing called exceptions. And so we can raise an exception in our code. I'm going to make this a bit bigger. By instead of just printing out this message, by writing the word, and I'll make this wider here as well, so that everything fits on the screen, the raise keyword, followed by the type of error that this is. Runtime error. In the notes here, there's a link to the documentation which lists all the different kinds of errors you can raise. In this situation, it's an error which has occurred while the program's running, and so raising a runtime error makes sense. It's up to you to decide what kind of error makes sense for your situation. So now when we exercise that code and we make our dog, and if we try and exercise it too many times, we get an error raised, a deliberate error which tells us that a runtime error was raised and the dog is tired. If we look at where the lines of code raise the error, we see that it's telling us in the exercise function on line 15, we raise the error, but that was called from these lines of code here, which are these lines of code here, and you see it's stopped on line 2. It's tried to exercise it this second time, hasn't been able to, and so these other 2 lines of code here will never ever run. It's forcing us to make the decision about how we deal with this problem. Now there's a few ways that you can deal with an error that's being raised like this, but one of the most common is using what's called a try except state. A try except block is going to try and run some code, but if an exception or error is raised, it's going to allow us to run a different bit of code to kind of deal with the error that we're seeing. So we write try, and then we put this code in here. So we're going to try and do this, except if there's a runtime error raised, in which case we are going to print something out. And see, now when we run this, it says something went wrong. So this code was attempted to be run, a runtime error was raised, and so this message gets printed out. That's good, we were able to catch the error and deal with the situation, but we've lost the information about why it failed. And so what we can do in this situation is take the error that was raised, capture it, and give it a name by writing as E. Then if we turn this into an F string, we can put E as a parameter inside the F string. So now when we run this, we get something went wrong with trying to access the dog, and then the contents of that error printed out. So printing a logging message when you've got an exception raised is a useful thing to do, but in some situations you can actually deal with the error and fix it in that situation. So for example, we have our try block still, but here inside the exception handler, this except state here, if the dog has run out of energy, we can try and feed it. And if we feed it, then we will be able to exercise it. So we've tried to do these lines. If any of them fail due to a lack of energy, then we end up in this block, at which point we can feed it and try and exercise it once more. So when we run this, we see that one of these lines failed, presumably the first, because we never saw an exercise line be printed. It's gone to this section here, where it has fed the dog, and then it's able to successfully take it for a walk without any further exceptions being raised. So for your homework after this session is to take the ideas that we had here with catching errors and raising them and apply them to the encode and decode code that we have inside our Morse code translator. If you try and translate code in Morse code which contains exclamation marks or @ signs or pound signs, anything like that, it's going to fail. So the exercise at the bottom of the handling errors chapter, I'll leave as homework for you, and it's to take this same idea of try excepts to catch the errors as they're raised and to practice applying the try except statement to them to make sure you get a sensible error message printed out. On the very last page on the notes, there's a link to our summary, which goes through what we learned today, as well as some links to the notes for some of our future courses. So do feel free to have a look at the notes for those and sign up for any of those courses if we're running them in the future. With that, I'll just say again, thank you all very much for being here today. Really great session, and I look forward to seeing hopefully all of you in one of our future courses. Bye-bye.